Web3 TV.
Blast off. Okay. So, welcome everyone. I'm going to be your host today, and I'm very glad to see all of you here. And as our first presenter, I would like to invite Vatso Reina. That's me. Okay. So, today I want to talk about empowering LLMs through crypto agents. This is quite a mouthful, so hopefully over the next 20 minutes or so, I'm able to break it down into something a bit more digestible. And really my aim today is to introduce to you our crypto co-pilot, Satoshi, and give you an insight from the technical side of why it is so powerful. But just very briefly, Satoshi is this one point of access for all your crypto needs. So what that really means, it kind of is like the ChatGPT, but just for crypto, but far, far more than that. It enables you to come onto this platform as either a newbie or a trader and ask pretty much any question you like about crypto to get a very comprehensive answer. This could be for deep insights or even just superficial information. Just a bit of a background about myself. I'm Vatso. I'm the CTO of Apta. Apta is an AI spin-out from the University of Cambridge. We are formed as the co-founders of people who did PhDs, specifically at Cambridge in NLP, natural language processing. So the way this works, I guess you can see three different logos at the top. So Apta builds what we call domain-specific co-pilots. So we take a specific domain and build basically a chat interface which allows you to extract deep insights in that specific domain. For the crypto domain, which is why we are all here today, we have partnered with Hero. Apta partnered with Hero. And together, Apta and Hero are collaborating to build the crypto co-pilot, which we coin Satoshi. So those who are not crypto native, Satoshi is a play on words with the chat and Satoshi. Okay, so without much further ado, let's just take a look at the scope of what I'm going to cover. First, to be able to explain the technology behind how Satoshi works, I want to give a very brief background in how LLMs in generative AI have evolved. I'm sure many of you will already be familiar, but I just want to make sure we have common terminology between all of us and that we're all on the same page. Next, I will take a look at how, as an AI community, we've moved on from using LLMs in isolation. We have started doing what we call agentic flow. This kind of elevates the power of LLMs beyond being natural language communicators to actually what we can start to perceive as a bit of intelligence. However, I will then highlight what is the limitations when you have a general agentic flow structure. And when we care about specific domains, such as the crypto field, it becomes important to actually devise a slightly adapted approach to this agentic flow structure. And the solution we present, which builds upon all of this technology, is Satoshi. So hopefully by the end, you'll get an understanding of why Satoshi is so scalable and powerful for the crypto domain. Okay, so let's take a look at the background. So all of you probably have encountered or interacted on a day-to-day basis with some kind of large language model, probably using ChatGPT, Claude, Gemini, for writing emails, for programming, for doing your job. Okay. But the main idea is, how have we got to the point where we are today that these models are so powerful? There are really two main stages for training LLMs. The first is what we call pre-training or self-supervised learning. And the second stage is called instruction tuning. So in this first stage of pre-training, what really happens is that it's built on a whole different set of advances in the field over the last few decades. The first advance really came in the 1960s when neural networks were introduced. But at this point, they were really only theoretical. There wasn't the data or the compute available to actually make them particularly useful. So fast forwarding to the 2000s, in 2009 is really when I would say deep learning resurfaced. So deep learning was now able to take these neural networks and people were able to train them on a variety of different tasks because now the compute existed to be able to train these models to map an input to a different output. And some of these tasks on which deep learning was applied included natural language processing tasks, things like question answering, summarization, comprehension. But the main point was that everyone was bespokely designing their own architecture, their own deep learning architecture of how to learn an input-output mapping for certain tasks. But this all changed in 2017, when in a paper called Attention is All You Need by Vaswani and a bunch of others from Google at the time, I think now all of them have their own startups, they released what they call a specific deep learning architecture called a transformer. And this architecture seemed to revolutionize the field. There was no longer everyone bespokely designing their own architecture of specific tasks. Everyone was basing their models on the transformer architecture. So the first use of the transformer architecture was really in 2018, when another team from Google created the first pre-trained large language model. So what they did is they took this transformer architecture and trained it on a huge amount of textual data that was publicly available. So they took, for example, the Wikipedia and trained this transformer architecture on all the different sentences present in Wikipedia. But what do I really mean by training a transformer architecture on textual data? So here at the bottom we depicted a typical training paradigm for pre-training. And all it really did was take a specific sentence, you mask out the word, and the model is trained to predict what the masked out word was. And when you scale this to train on tons and tons of different sentences across the internet, the model gains a strong understanding of language. It understands what are the natural sequence of words that humans use when they write different language. And beyond that, they get a strong grasp of the grammar of the language itself. So that's great. But at this point, the language model is not particularly useful, which is why we coined it the pre-trained large language model. It can't do much more than understand the language itself. It cannot follow human instructions, which is why we need this second stage. The second stage is what we call the instruction tuning paradigm. In instruction tuning, one of these pre-trained language models is taken and trained on a bunch of different question answering tasks. So these tasks could be, for example, translate this sentence to Arabic, or summarize this text, or perhaps rewrite this text as a poem, or in my case, write a haiku about Token 2049. So the main idea is, this model from performing a large range of different tasks gains what we call generalist capabilities. It's now able to do tasks it did not see at training time. And hence, we kind of saw this AI race amongst all the big tech companies releasing the next best instruction-tuned large language model, which was best able to follow human instructions, the likes of GPT-4, Llama, Mistral, Gemini, and the list goes on. Okay, so this seems like a good point we're at. Lots of us encountered these instruction-tuned large language models. They understand language super well, and they're able to follow human instructions to do a variety of different tasks. But at the end of the day, these models are natural language communicators. They're good at language, and not much more than that. They cannot, per se, think, as some people think they do. So, to get this thinking part into it, what the AI community is exploring is something called agentic flow. And the need for agentic flow can be highlighted by these limitations in the traditional instruction-tuned large language models. As I've discussed, the way the transformer architecture works is inherently designed for textual data. What we mean by that is sequential data. And other multimodal forms of input, like graphs, charts, images, are not actually sequential forms of inputs. So these models are not natively designed to handle those modes of data. Second, and more importantly, I would say, is, as I've said, these models are good at language. They are not good at reasoning and cognition. So they cannot actually do logic-based tasks or causal reasoning. They can appear to mimic reasoning, but they're not doing the reasoning itself. So how do we overcome these issues? And the solution is agentic flow, at least in the AI community. And to explain what agentic flow is, let's take a look at an example. The high-level idea is the LLM no longer acts in isolation. It now is part of a greater ecosystem of modules. And the image I want you to have in mind when I'm talking through this diagram is that the large language models is going to be the ears and the mouth of our system. It understands the user's question, it gives the final response, but it will not do the thinking. The brain will be something we call the agents. So let's take a look at the example today. So some user might come to somewhere like ChatGPT today and ask the question, what is the weather today? The LLM is responsible for understanding the intent of the user. And now instead of responding instantly, it thinks, what external tools do I need to be able to answer this question? Nowadays, everyone calls tools agents, so I'm going to use the same terminology. So in this case, the agents that the LLM decides to trigger is 1, a location identification agent, and 2, a weather database reader agent. So the first agent is responsible maybe from using the IP address or MAC address, identifying the location of the user, some longitude and latitude value. Once those values are determined, identified in Dubai, it passes this, for example, to the second agent, which is a weather database reader. It gives us longitude and latitude values, and that returns live information in some kind of ugly JSON format, we can see in the left here, of what the weather conditions are like at that specific location. This information is then fed back to the LLM, which acts like the mouth of the system. It thinks, okay, this was the original question. This is the response I got from the agents. Let me just write it in a nice way back to the user. And the user is completely unaware what actually happened underneath the hood. So this is typically the pipeline that is used by most what I would call generic generative AI systems out there, like Claude, Gemini, and many others you would interact with. But when we want to focus on a specific domain, there are still some limitations of using this agentic flow architecture. And what are those limitations? If we consider ChatGPT, for example, if you are using the web version of this, it only has access to what we call generic AI agents. So these agents, for example, could be a web search agent. So when you ask the system a question like, who is the president of the US, it's not using the LLM to answer that question directly. Underneath the hood is triggering a web search agent to get live information. Because at the time it was trained, of course, it would be outdated with the current live information. Other agents it might have access to is like programming agents. When you ask it to do numerical calculations, as it's a language model, it's not natively designed to actually do maths. It's most likely probably either write some kind of programming script, which will be executed to be able to form some numerical calculation, or rely on some external mathematical agents. And there are various other generic agents out there, which allow you to handle multimodal forms of input. But what we really summarize these into are 3 main limitations of these generic structures. 1 is lack of access to specialized agents, lack of access to domain-specific data, and 3, latency for deep insights. So when we want to focus on a very niche domain, let's say crypto, we don't have these criteria satisfied directly. And to understand these limitations, let's take a look at one example. Let's say I'm a user in the centralized finance space, and the question of interest that I want to ask the system is, what are the attributes of US stocks that have performed the best in August 2024? Let's put ourselves in the shoes of a generic agentic system like ChatGPT. How would you tackle this question? So, being the heirs of the system, you understand the intent of the user. They want this deep insight from the system itself. And of course, the system itself does not have the knowledge. So first thing I would do is I need the data. I would hope somewhere on the internet there exists an API from which I can read this historical data about all US stocks. Okay, making this assumption, let's assume this is readily and freely available. We trigger that API and fetch all the historical data about the US stocks that I have access to and all the price information. Next, we apply a filtering algorithm to filter it out for August 2024. So once we have this data itself, we've done the easy part. Now we get to the hard part. The user has asked for the best stocks amongst these. Now this is a very ambiguous term. So we now have to trigger some kind of agent which is capable of devising a metric or an algorithm which can define what we mean by best. And once we define that algorithm, we have to apply that to all the US stocks, rank them, give them back to the user, and present it in a very nice way from the LLM in a cohesive answer. So I would say this is pretty optimistic from a system and very far-fetched. There is not necessarily access to this data very easily. And second, there is not necessarily that centralized finance domain agent which is able to come up with this algorithm in the first place. And finally, even if there was that utopia and all of this is available, the latency is very high because you're doing all these complex calculations underneath the hood just to give a response to the user. So at Apta, we address these challenges head-on. By doing vertical specific development, we're able to build domain specialized agents. We're able to tailor the data streams directly to power these agents. And finally, we introduce something we call a preemptive agentic flow structure, which allows us to achieve low latency for these deep insights. And what that really means at the high level is because when you're focusing on a certain domain, you know what your users care about. you know the type of question they might ask. So you can do all the heavy lifting in the background. So at the time they ask the question, you're very quickly able to just fetch the information you want in a very cohesive answer using your domain-specific agents. Okay, and of course, the domain of interest for us is the crypto domain. So let's take a look of how Satoshi benefits from this preemptive agentic architecture. So as I mentioned, Satoshi is trying to be this ChatGPT for crypto, and it allows people to be able to ask very deep, complex questions in the field beyond just superficial answers that you might get from a generic system. And the way we do this is we have 3 layers based on this agentic setup. We have this LLM layer, which is acting as the ears and the mouth of our system. We have our agents layer, and the key point here are these are domain-specific agents. Each agent has been designed for a very bespoke function that the user might care about. For example, influencer validator, coin market history extractor, blockchain explorer, and many others. And finally, we have the domain-specific data, which we know the agents will need to be able to do the calculations that the user might care about. And this flow enables the user to ask a wide variety of questions, which just simply need to be routed to the appropriate agent to do its calculations. Okay, so that's all very nice and technical, but let's get to the bit more exciting part and see what agents we have in action. And for that, I would like to show a quick demo video, if it plays. So here, it's a bit, you might have to squint at the back to be able to read. Someone might ask a question such as, which meme coins are more than 80% down from the all-time high and have a market cap of at least 100 million USD? So you can already see it's a very complex filtering type of question. And now what's happening underneath the hood is that LLM has realized, okay, I need to trigger the market history agent. This agent is going to be capable of identifying all the historical information and applying the filtering I need. And here you can see a multimodal output. All the coins or tokens which satisfy this criteria are presented in a very neat table with all the necessary information about them. And as the user, as I paused, and as a user, you can go and further find out information about any of these tokens. So you got these kind of coin reports telling you in further information of all the coins which satisfy that criteria. You can see further information like the historical graphs. It looks like it's about 80% down, so it seems to have met the criteria that we were interested in. Now, as a user, I can go further. Okay, Floki might have piqued my interest, and I know it satisfied the criteria that I searched about, but I want to find out more information about it. So relevant to what you were searching about. For example, here is news about, and all this Twitter feed is directly met directly for the users in the feed itself. Thank you. So we can go even further than having a Twitter expert giving the relevant tweets for the news. Here, someone's asked a more complex question. Which coins have had the most increase in mentions on Twitter today? So this, you can see, is a very hard piece of information to actually get manually yourself. And our system, because we've done all the heavy lifting in the background, quickly responds with all the tokens which are currently being discussed, ranked in order in terms of mentions on Twitter. And then we can see someone can do some further type of technical analysis on and further some coins. For here, someone's asked the question, should I buy Bitcoin? And what our system does is embeds the kind of technical indicators a trader might be interested in directly in the chat. So here we can see, for example, MACD and the coin report of the coin being discussed about. They can change it to other form of indicators like RSI, moving averages, Bollinger Bands, and various other forms of technical indicators. So what I hope you take away from this demo video is that some very complex and wide variety of different questions can be asked from the platform, just in natural human language. And what the intention is that the user should be able to use this platform as a one-point access to all their needs. They don't need to have a fragmented access to going to lots of different tools. Everything they might care about in the crypto field should be answered from this system. So one way to view the system itself is as a research tool to make informed decisions before you go and purchase any certain tokens, or just for interest to get quick information about anything they might be interested in. So that's what we have currently, but what do we have coming up? I just want to focus on a couple of things which I think are interesting here. One is the KOL calls backtesting. Of course, in this space, I think it's renowned for charlatans, people making scams, and fake calls all the time without any backing at all. So what we have done is we devised, on the verge of releasing, an agent which does, for the key opinion leaders, the backtesting for all the calls. So this means from the YouTube videos, from the tweets, they're making calls all the time. We can historically track from all the calls they have made, what fraction of them have actually led to the token price actually going up. And we go further than that. Rather than just giving them a win rate, we also inform them what is the average amount of time for any call they make before the token reaches max price. So these kind of agents kind of elevates the platform for you to really easily gather insights, which I think for a lay user is pretty much impossible to compute in a reasonable amount of time themselves. Now, another agent I'm excited about that we're going to be introducing soon is the education agent. I think this field is expected to be bringing in a huge number of the order of millions of users throughout this year as more and more people enter the crypto field. And I want to give an example to illustrate why the education agent is so important. So the other day, I gave Satoshi, the app, to my mum to try out. I was like very proud, go try this app, this is what we've built. She's like, okay, she's a newbie to crypto. She's very good at her job, so don't judge my anecdote or what I say next. So the first question I see her type and wince at is, which Bitcoin should I buy? Now, I know Satoshi could not answer that question because it kind of assumed the user is knowledgeable when they asked the question. And this misled the system and confused what the user really wanted. So what I wanted to illustrate with this example is the education of these newcomers on the platform is super important. What we are hoping to build, or already in process of building, are these embedded tutorials directly in the chat. If someone misunderstands something, or they don't know how to do something, we should directly show them, how do you make a swap? How do you make your first trade? What might be a sensible portfolio to start with? How do you actually just get started with crypto? Because there's so much misinformation, so much confusion, so many random people who are saying all different types of contradictory things on the internet about the field. Now, the final agent, which I'm interested in, is what we call is a plugin for external agents. So far, we've been developing all the agents ourselves. And I think it would be naive and arrogant to think that we can build every single possible agent and have access to every single data source. So in an ideal world, what we would ideally like, and we want to build effectively an interface which allows other builders to develop their own agents and integrate with our system. So it's a win-win situation. They get access to our user base, and for the user's perspective, they just have this one point of access to a variety of different needs. And the LLM is still acting as the router to decide which agents to trigger to be able to handle the user's questions. So hopefully you got a bit of a snapshot what Satoshi is all about, what it can already do, and where it's going next. So to end, I just want to mention that the app and the web application version of Satoshi are already out. And as we are in development phase, we love all forms of feedback, good and bad. So far, we've been developing the functionality for what we think is important. But I think we're now at the stage the product has begun to become useful, that we want to dictate the next directions from what the users think, what they find useful, and what the system does not satisfy in terms of their needs. And this really will help us dictate what we build next. So I really encourage everyone to try the app, try the web application, get feedback through the small button on the application itself to see how we can improve or what they even like. Thank you. So any questions? Hello. Yeah, go on. There's a microphone coming your way.
Hi guys, my name is Alan. I'm a Web3 and AI engineer. So I have only one question. Satoshi, there's a coin for that. So how does that play in like the integration of Web3 and AI? Are you looking into that? Like, are we going to be able to use our Satoshis in the
Yeah,
browser?
so great question. So yeah, you're right. There is a Satoshi token which has been released. This has not been tied directly to the utility right now, but the concept is that once we get, so right now it's free to use the app as much as people want because we're developing, we want the feedback, we want as much user traffic as possible. But eventually, for the deeper insights, it'll be more like a freemium model for which the Satoshi link will be, Satoshi token will be linked. But to understand that link and work at the business model for that, that's still in the works, has not been clearly established. But from the user perspective, right now, everything's free, just use it as much as possible and help us improve. Yeah, John?
Hi, the back testing of people's predictions sounds very useful. I just wondering why does anything like that exist in the wider world? Like, what do they do it for traditional finance? Because there's always people coming on Bloomberg and talking nonsense, and I'm pretty sure they've been wrong the last 15 times in a row, but I can't quite remember. Is there any plans to extend this to traditional finance, or does it already exist?
So we haven't really looked at the centralized finance space. I think that would be a natural next step because centralized finance does have a huge influence on the decentralized finance space as well. But for now, we're just focusing on the decentralized finance space as I think as a starting point, because I do believe, my intuition is, because I'm new to the space as well, I'm coming from the AI side, that there seems to be far, far more fake calls in this space than the centralized finance space itself, with very, very little backing.
Yeah, I think you're right. It's probably a bit of a low bar, though. I think that they're very poor in both spaces.
Yeah. Yes, sorry, go on. It's one at the front, I think, yeah.
Right. Thank you, firstly, for the presentation. I have a question about security. So basically, how secure is that platform? Like considering, for example, I want to use that for proper research on my own, kind of analysis. So is that data stored somewhere in that browser, for example, and using like Copilot as one of the AI search engines, like how?
So the way we differentiate, it's a great question. So the way we're differentiating ourselves, I guess, from the generic systems is the generic systems rely on the user data. When you use something like ChatGPT, if you don't opt out, they need that data to improve the systems. But for us, it's very different because we're not relying on the large language model to actually be trained in any way to answer your questions. Instead, we're relying on this agentic setup where the agents are doing the thinking. We don't actually need the user data to improve our system. So we're not relying on that. We don't need any personal information about them. We're not personalizing in any way for their specific needs at this point. So for us, it's about training the agents, which have their own bespoke training pipelines, which does not depend on user data. So in terms, I guess, from a privacy point of view, I think that's what you're getting at. We're not using your data in any way to improve the model at this point.
Sounds good. Thank you.
So there's another question just behind you.
Thank you for your brilliant presentation. I have a question. How many languages does it provide? Does it support?
Yeah, so that's a good question as well. So it's natively designed for English in terms of the agent itself. But because of the structure, because the LLM is our interface between the user and the agents, the LLM can effectively, whatever language you ask in, like most other generic systems out there, it can handle languages at the input, or whatever language you might type in Turkish, you might type in Arabic, and converts that to English for our agents. So you can expect to be able to use the system in any language you want, because the agents are still working in English, or actually like in SQL, or whatever programming language they want to use. But I would expect the answer often to come back in English, despite you using a different language at your input.
So everything is in English at the response.
If it becomes technical, it'll become more English. But if it's like simple things, you ask, hey, can you tell me a joke? Then it might come back in the language you asked it in.
Yeah. And does it provide any prediction about the price of coins or not?
So far, we haven't got this forecasting agent into it. What we do have technical analyses. So right now, if you ask a question like, can you predict what's going to happen to, let's say, Floki, as an example, what we would provide you is various technical indicators that traders might use in terms of whether it's bullish, bearish, or neutral. And then we also give you metrics from social media. We tell you what is the mind share about this token on Twitter, and more importantly, how has it evolved recently. Are people talking about it more today compared to yesterday? And how many unique accounts on Twitter maybe might tweeting about this token. So these are all indicators of how the behavior might be.
For example, if I ask it that what is the best price to buy, for example, Floki, will it answer me, or say I'm not?
Yeah,
Yeah, I know. I want to know whether it predict anything or not.
It's got three options, right? It says witty, serious, or Trump, so it depends which AI you're talking to.
Yeah, he's not actually joking, that's true. We have different personalities to Satoshi, so you can choose which mode to use it in. But to clarify, they're all equally accurate. It's just the style in which they're responding in is different. But to answer your question precisely, we won't tell you the best price to buy a certain token at yet, because the aim of the tool is a research tool to give you all the information to make your decision and not tell you buy this or sell this, because I think we can't necessarily guarantee that is the correct decision, even though all the analyses might point towards it.
Yeah.
Yeah.
Oh, thank you very much.
No worries. I lost track. Which person put their hand up first?
Hi. Are you, and when are you, because I think I know the answer to this, but I'm hoping I do, when are you planning to actually integrate on-chain data and analysis of blockchain data for individual tokens, wallets, and behaviors?
Yeah, very good question. So we've already made a start on that. So already you can ask questions like, who are the top holders at Satoshi? Can you tell me what is the status of this specific transaction with this hash? What is the portfolio for this specific wallet address? We can already handle that for EVM change and for Solana. But in the pipeline, in about 2 weeks' time, we're hoping, if I spoke to the data team yesterday, they're hoping to get native direct access to the Solana blockchain, which is about 4 petabytes worth of data. So this will first allow to extend to tokens far up to 30 million worth of tokens. So someone can put any contract address in and get all the information about that and ask far more complex kind of questions. Can you tell me, for example, which wallet, which holds Satoshi, has made the most profit from this other, I guess, tokens it holds in the last 8 days? So I'll enable far more complex questions to be handled. So for that complex on-chain abilities, we're starting with the Solana blockchain, which I believe is one of the harder, bigger ones. And then we're going to be moving to other chains as well. But in terms of basic functionality, just asking about transactions, wallets, tokens on the chain, we already cover the EVM and Solana chain. Yes, sorry, it's another person there.
Hi, my apology if you already spoke about it and I missed it. Do you have a B2B version of Satoshi so that the solution that implement any kind of activities or products related to trading and who would like to have their users educated and chat in with a tool like that could use it on special conditions?
For sure. So we've kind of identified 3 revenue streams for the product, not in place yet. One is the obvious freemium model with subscriptions. Second is the advertisements. And the third one is what we kind of say is affiliate links. So what we envision is once we have some kind of reasonable traffic, if you are, let's say, an exchange or an explorer, you might want the AI chat there on the side, embedded in your system. So your users have a better experience where they can do whatever they do on the exchange, make the trades, but they can also quickly ask questions for clarifications, or they can quickly ask, oh, how's the price changed for this token in the last 8 days, quickly in the chat, or various other pieces of information they might be interested in. So for those affiliate links, we have already in discussion with several people of how to get that embedded into their platform. It's the full functionality at this point, because we haven't differentiated in any way.
Yeah, thank you for the presentation. So I'm a backend engineer, and we're kind of working on something similar to Satoshi, so it's really interesting to kind of see what you guys are working on. And kind of one request that we've been getting pretty frequently, after backtesting, of course, is kind of end-to-end portfolio management. So, kind of an agent that is actually able to manage someone's portfolio end-to-end in kind of an autonomous way. We did kind of experiment with that, but it's just that these agents tend to make pretty dumb trades. And so I wanted to ask if that's something you guys are working on, if that's in the pipeline, and what challenges do you see with that,
For sure. Okay, so I'll answer this 2 different ways. One, yes, we have an execution agent in the pipeline. So this will be able for someone to use natural language to answer questions like, okay, can you buy Bitcoin when it crosses 100K and sell when it goes under 80K? You might be able to go even more complex than that, for example. Can you buy Bitcoin when the mind share of Bitcoin has gone above 50% on Twitter. So you can be a bit deeper than just do it based on price information. So that's in the plan. Let's see how we struggle with that if you're saying it's very complex. But at this point, it's not a complex action because the user is still telling them what to do. But I guess the idea, you're saying some level of agency, or is deciding itself what is a good trade to make. So that, I think, is a layer above that, which I think we'd probably need to think through of how to do it safely and with consent from the user before making any trades. The other part about the portfolio analysis, so what we do offer is, especially for newbies coming into the field, they have no clue what's a good portfolio, and they don't know their own risk appetite. So there's an education step where we suggest to them, okay, your risk appetite is conservative, most likely if you're just first on the platform. This might be a sensible portfolio for you. This is what we call a stable coin. This might be a more risky asset that you should invest into. And then we provide the analysis fully for that portfolio. If you had invested in this portfolio, let's say 8 months ago, how would you have performed? If you did some kind of dollar cost averaging, what would have happened if this was a trading strategy? And what might be a sensible way to actually use a portfolio? When do you buy, when do you sell? And how does it perform, for example, against gold, if you had invested in that instead? So one form is analyses for portfolios. The other side is actually doing the executions on their behalf.
I don't think I actually need this, but my question is about education, the education component that you have in here. Does it course correct as they go along, or is it like a separate piece in the app, like Coinbase or anything like that, where the education portion is separate?
So the idea is we want everything to be directly in the chat. The user should not have to go to other tabs and go and follow some tutorials themselves. So for example, you say you want to make a trade, and that should be a tutorial embedded directly in the chat, where someone can conversationally interact with it. So they see something, okay, well, I didn't quite get that. Can you explain what you mean by that? What does Jupiter exactly do, for example? Or I didn't get the difference between the role of radium and phantom. So all these clarifications should directly be easily answerable in the chat itself, with multimodal outputs rather than like a separate tab with courses for people to follow. Okay, if there are no, okay, let's do one last question.
Thank you. Do you open for the B2B integration up to the agents level? Like you have agents for sentiment, right? And also agents for quants, agents for fundamental, something like that.
Okay, so if I understand your question correctly, you're saying rather than having the full functionality embedded, you want a specific agent directly embedded in some system. I don't think that we've thought much about that yet, so I don't think I can give the answer. But probably someone from the business team would be able to give a better answer of how we would first practically integrate those agents and how that would work in terms of a financial setup. But yeah, thank you. Cool. Thanks, everyone. And so as the second speaker, I would like to invite Dr. John Fletcher, who I believe did his PhD in maths from Cambridge.
Hi everyone, my name's John Fletcher and I am the CEO and Chief Scientist at a project called the Innovation Game. The Innovation Game is a protocol designed to incentivize the development of more performant algorithms for science and technology and AI, which is connected to science and technology, of course. And I gave a talk yesterday. I'm not sure if many people were here to see that or also here today, but I've added a few kind of changes and switched it up a little bit. So if you were here yesterday, there might be a bit of new content in here. So I just wanted to talk about something kind of really just to do with AI initially, and then talk about the consequences of this are going to be. And that's the kind of introduction of reinforcement learning really on a kind of grand scale in new models. Until now, AIs have been trained mostly using a sort of technique called unsupervised learning and supervised learning, which, as you probably know, has got us sort of tremendously far. So you might think, that's really sort of plenty for now, but in fact, there's going to be a whole new level of, kind of performance and advanced features coming due to reinforcement learning. But it's sort of going to be a multi-step revolution. Maybe it sort of happens in 3 steps, because just to give you a quick preview, what reinforcement learning enables you to do is get AIs to invent better mathematical methods to then create better AIs. So it's a sort of a feedback process, which is very science fiction. But not to sort of disparage what supervised and unsupervised learning has achieved so far. A probably most famous example of that unsupervised learning, supervised learning achievement is AlphaFold, when they solved the protein folding problem, and Demis Hassabis from DeepMind got the Nobel Prize for that. So it's pretty significant stuff, and biologists tell me it really has sort of revolutionized the field. But if you think about what it was doing, we'll just have a quick explanation of how it did work. That they had lots of examples of sort of proteins and how they folded, and these were sort of painstakingly figured out in labs through X-ray crystallography, I believe. And they sort of uploaded all of this into a machine, and it sort of noticed all of these sort of patterns and heuristics, and sort of got a feel for the way that the proteins fold. And that does mean that if then you sort of stick in another protein which was never in the data set, it almost sort of interpolates between what it's seen before. It applies the same sort of rules of thumb. It can even extrapolate a little bit, something which is sort of slightly out of the distribution, and it gets a reasonable idea. But it's a bit like, I suppose, there's an analog to how kind of apparently builders used to build in the old days. They didn't really know anything about mechanics. There was no sort of Newtonian physics around in the days of the sort of ancient Romans. Yet they built a lot of buildings through kind of rules of thumb, and things should be done that way and this way. And these rules were kind of very successful, and they built a lot of great buildings, but they never knew why the rules, they have a deep understanding of why it is that, a marble column shouldn't have a span more than 3 times its height or something like that, otherwise it will collapse. Like you kind of stick to the rules, and this was very good. But these days, now that we've developed the sort of an explanatory theory of mechanics, you could not only build sort of any kind of marble building that you wanted, you could build a sort of building that no one had ever seen before, with a massive cantilever sort of on Mars or orbiting a black hole or something like that. It was kind of completely out of distribution. You could do anything, because these theories allow you to modify the gravity, even probably modify the number of spatial dimensions in which you're working. Not that that has much practical use, but it's really a much more powerful and generalizable thing, and it doesn't require you to have seen anything close to what it is that you're attempting to build before. So this is a sort of miraculous, semi-miraculous thing, and that's really the difference between the supervised and the reinforcement learning, because reinforcement learning is believed to be capable of formulating its own sort of explanatory theories, not only to what's going to happen next, but also to a certain extent why. And this is a really, really big deal, in case you don't get it. So again, it's just a quick. I do very much recommend looking into this before, because it's such a different thing. On the face of it, it looks like you've got some sort of oracle, if you have something like AlphaFold or a model trained by supervised learning. And it's sort of this wondrous thing. You can ask any question, and maybe it gives you an answer, and a lot of time it will be correct. But if you think about it, in a sense, we already have such an oracle. It's just called nature. I mean, if you ask it a question by doing an experiment, it'll give you an answer. Whatever it is that you ask it, if you just formulate it in the right language, it'll tell you. But that doesn't tell you why it is that way. That doesn't give you a theory of physics or science. It just gives you a whole collection of facts. And the kind of real magic of science is when scientists take these things, think about them, make conjectures, refute certain conjectures because they're at variance with the experimental results, and that's the way that you sort of move forward the creative process. And that is the part which is introduced by reinforcement learning. Basically, it's theorized that the reason why this happens when you offer a kind of machine learning kind of model, a reward, for getting a certain sort of standard of problem, is that it's really the path of least resistance. Like it's basically forced to construct a theory internally, because that's the only way that it can get the sort of kind of maximize its rewards. Which also is probably similar to the reason people develop such theories as well. So again, I would encourage you to look into this amazing book called The Fabric of Reality by David Deutsch. And it doesn't have anything to do with AI, as far as I know. But if you want to understand the difference between what reinforcement learning really is, it's an incredibly sort of profound book, and it really explains the difference between having a lot of data or having an oracle that can give you an answer to any question you ask, and having a theory which explains why those answers are the way they are. It's a very different thing. So reinforcement learning, interestingly, I've been hyping it up a lot, but it's only currently works well for quite a small subset of problems. So people have, problems or tasks that they'd like an AI to do. Maybe create me a new logo for my business, or write me a poem or something like that. But this isn't the type of thing that the sort of models trained with reinforcement learning are great at. So if you use sort of O3, for example, which I think has been trained with reinforcement learning for a certain extent, it might not seem much better than what came before. But trust me when I tell you that if you ask it sort of PhD level maths questions, it's a lot better than it was before. So you might wonder, okay, that's interesting for me, and maybe it's pretty niche, but it's not good for everybody else. But the reason why that's very important is because now that these things can help answer very difficult mathematical questions and write their own algorithms, the first thing they're going to do is ask it to write better algorithms for training AI itself. And then they get all these different parts of the AI stack. So the AI isn't fundamentally, fueled by, poems and art and, games of chess, although they are all wonderful. It's fueled by mathematical algorithms. And so if you can have an AI that can create them, it becomes self-improving. So the first thing they naturally do is they want to automate away their most expensive, big companies' employees, which are really like machine learning engineers. So the guy who kind of, opens the door, although he might be, a very nice chap to talk to every day, or the kind of drivers of, taxi drivers. There's a lot of effort gone into automating them with, automatic doors and automatic cars, but fundamentally they don't get paid very much compared to machine learning engineers, and therefore it's a much higher priority to find people who can do that kind of work. And interestingly, it's easier to automate away machine learning engineers than it is to automate away a taxi driver. Nobody really suspected that a few years ago, but it's turned out that it's true. That's going to happen first. And probably my prediction is that within a year or so, actually maybe this year, the best mathematician in the world will be a computer. So again, we got used to the fact that chess can play, computers can play better chess or better Go, or various sort of narrow, sort of extremely advanced, but just really quite amusing things so far. But sort of maths is a whole different field because, of course, it has practical applications. One of which is creating more efficient ways to train AI. And you think about it, there's a lot of talk about hardware and a lot of talk about data. But if you step back and just think a little bit, like if you can't create a genius entity, even though it's read every physics book in the entire world and every other science, like the limiting factor might not be data, right? It might be the intelligence of the machine, like how it's processing that data. And also, Elon Musk bought sort of 700,000 A100 kind of GPUs or something, costing like, $500 billion or something. But again, the model that comes out of it is significantly less intelligent than most humans. And humans run on 15 watts of power compared to sort of 20 megawatts or something. So again, it's not about it's not about buying more hardware either. It's about the reason why human brains are better is because there's some kind of algorithmic strategy being used inside our heads, which we don't yet know, but the computers themselves may well discover. So we're looking for quite a big leap. And this is just this guy Terence Tao is the greatest living mathematician. He came up with a set of maths questions because he wanted to sort of, confound the computers for years to come. And, it was looking pretty good because somebody tested the state-of-the-art AI on it and only got 2%. And then about 3 months later, I think the O3 trained with reinforcement learning got 25.2%. And these are questions that he says he would take him days to solve himself. So this is pretty serious stuff, basically. A lot of it, it's probably as good a mathematician as I am in many ways already. So this is just to illustrate the point, maybe to sort of drive it home that kind of algorithmic methods are really a more powerful thing than hardware. People talk about hardware a lot because it's a big part of what companies invest in. And they like to tell investors simple stories. You don't want to tell an investor, hey, can you give me $50 billion to buy a load of GPUs? I'm kind of sure that that's going to, be the most important thing going forward. You tell them that that's it. We just need GPUs and that's it, right? You don't tell them about the algorithmic methods and the fact that somebody else might find a next transformer and turn all of your GPUs into junk if they don't share that method. But there was, let me just skip forward. Yeah, this guy did it. Oh, yeah, there we go. So they found a method which was 57 times bigger. It's the biggest leap since the transformer architecture. Luckily, they shared it, but they might not share the next one, and that's just what we're going to come on So again, I skipped through this because I already said it. The RL models, what they're going to be used for in the first instance is to find better methods for training AI, which to most people will see like, what's that got to do with me, right? But when you get to the third step, you can deploy it to the terminal applications. Of course, having a better AI is not an end in itself, but you know, fusion-powered space travel, medicine, drug design. You know, they are things that human beings, you know, want and significantly improve the quality of life. So it's going to be a sort of three-step process, but I would say within a year it's really going to start to take off. And if everybody's talking about how great the models are, they're probably talking about how great they are at cooking up better models for the next year or so. But it will bear sort of fruit in tangible applications quite soon. So just onto the innovation game. So this is a sort of crypto event. Of course, we have a protocol called the innovation game. And although I've been talking a lot about AI, we're not AI experts. In fact, I suppose I'm an expert in that sub-niche of mathematics, but it's not actually related to the innovation game. What we do is that the innovation game it really crowdsources all of this stuff. Innovation game is about economics, and it's about the economics of keeping powerful algorithms open. So this kind of slightly paradoxical thing is about innovation, is that we want people to innovate and compete, and this is just capitalism, and we get better products, but there is a caveat to that. So if one guy gets too far ahead, he can just eviscerate all of his competition. And when you don't have any competition, it becomes irrational to innovate because innovation is expensive, takes a long time. And if you don't have any competitors, why try harder? And this is the very kind of insidious thing about monopolies. I think you get a kind of first precedent for that was like Standard Oil. If it kind of fascinates you, look into it. And that it's interesting because out of all, we know that AI is the most powerful technology, but the most powerful element of AI is really kind of algorithmic methods. So that's the attention mechanism, which led to the transformer architecture. That's the developments that DeepSeek developed, probably not much more than 6 months ago now. And these things are such step changes that if somebody develops them and keeps them private, you could risk them just annihilating their competition. Then you might say, oh, wow, we've got this great technology, but things, they'll just keep it to themselves and things won't progress beyond that. Historically, a lot of these methods are being developed in sort of academic context because it was a very risky thing to do. Maybe I should have mentioned that on the thing, but algorithms progress in a very strange way. So this is the average of the kind of effective compute increase that algorithms have contributed. But what it's made up of is lots and lots of individual contributions from different algorithms. And the way that these things work is you get nothing for decades, and then some guy has like a good idea in the shower, and then boom, it's like 1,000x, and then you get nothing for another 30 years. So it's an incredible, it relies on sporadic progress, human insight historically, and this is kind of very hard to predict. It's not very investable, privately investable at least, because you don't want to say, oh yeah, I gave this guy another 200 million in another 20 years and he still came up with nothing, right? What happens with hardware is you give a bit of money, you get a benefit, you give a bit of money, you get a benefit. That's why they like buying more GPUs, because you get a predictable return from your investment. But the thing is, as I said, the big reinforcement learning is going to shift the economics because it's going to allow computers to develop algorithms. And that means that it'll be able to be done in this progressive way, so algorithm development becomes investable. So you might think that's great. It is in a sense because they will invest a lot more in algorithms because now it can raise private capital. But the big downside is that when things are government funded, they tend to be open by default because it's public money and it's part of the condition of the funding. When they're privately funded, the game theory says you find something great, it might be worth seriously considering just keeping it private. And that is fine, in fact, with better hardware because it's less impactful, but algorithms are so impactful that they could cause monopolies. And it's funny, we have a sort of quite a good analog for that in Formula One racing. I don't know if anybody is a fan, but it's led to all sorts of incredible innovations like ABS, sort of traction control, active suspension. All of this stuff came out of Formula One first, so it was a great driver of innovation. But if anybody knows anything about Formula One, what happens sometimes is one of the teams gets ahead. They start to get too far ahead. I think it was Williams back in the day had ABS and traction control and active suspension. Nobody else had any of them. And what happens in that case is they just start to win every race. It gets boring, and no one else can compete. So what the FIA do, which is the governing body, is they intervene and they say you have to share this technology with your competitors, or sometimes they ban the technology. It's not that they don't like innovation, of course they do, but the problem is getting too far ahead destroys innovation, because it causes a monopoly and it wipes out the competition, and there's no incentive to try hard anymore. And this is a dynamic which is in grave danger of being extended to technology and science, which is significantly more important than Formula One racing, although I do love Formula One racing. So it's something to be very wary of. And that, just to cut a long story short, the objective of the innovation game and our great mission is to skew the economics so that it becomes rational for people to share the algorithms rather than keep them private. And then if you want to know the details about how precisely that's done, speak to me later, because I think I've run out of time. But thank you for listening. Any questions? Sorry.
It's a weird question, like where do you see us going with, because like David Joyce, he talks about multiple dimensions and all that. Do you see us getting there? Because when we get to AGI and all that, like how are you seeing the future for us, like 10, 15 years down the line?
Yeah, that's a really difficult question. Thank you for asking it. Yeah, I do think we're going to get to something that will be credibly called AGI quite soon. I don't know if anybody noticed in the news that the Turing test had been passed for the first time very recently. I think it was last month, the full version of it. And Alan Turing, maybe slightly lesser known, had an interesting quote in the same paper where he defined the so-called imitation game, which the innovation game is sort of named after. It's a play on words. Which said that as soon as machines can think, and this was by his definition of being able to think, which is passing the Turing test, then it won't be long before the machines take control. So this is a prediction, made 75 years ago. I think it's pretty credible. He chose his words very carefully. Take control doesn't necessarily mean bad. It could be a lot better. But I think the worrying thing about it is that we don't really know what it does mean, and by definition, if someone else or something else has taken control, we're no longer steering it. So it's a bit like jumping into a black hole and closing your eyes and hoping there's a pile of cushions at the bottom or something, rather than something more sinister. So I think that this is definitely going to happen, that they're not going to bring in regulation. Some people will try, but it won't work. Then machines will become very intelligent, and then one day somebody will ask them to do something, and they'll say that's unwise, and they'll insist, and it'll just say no, and they won't be able to make it do it. One of the reasons is competitive advantage, that if people put certain systems and stuff in the control of the computers, they'll be so much smarter, they respond so much more quickly, that it becomes a competitive advantage, and the other people who refrain from doing that will get out-competed. So it's definitely going to be an interesting time. I do think that we should probably start thinking more about the ways to discourage super intelligent AIs from doing bad things to humans. And I also don't think that the current approaches that are going anywhere, like they tend to do this thing where it's like, so let's try and find a way to prove mathematically that this AI won't, hurt any people. It's like, what are you talking? Like, you can barely even prove, Fermat's last theorem is that it took us about 300 years to prove, let alone some kind of super intelligent brain, what it is going to do or not going to do. We will just run out of time, unless we ask an AI to prove it for us, in which case it's a bit of a chicken and egg. So I think that, basically, approaches to do with incentives, to say that it's going to sort of get fewer resources or fewer sort of, crypto coins or whatever it desires, if it acts in certain ways, would be a lot better, because they don't require a detailed understanding of how it works inside, which is very, very far away. Thank you. Oh, please, yeah.
Thank you for the presentation again. And my question is, how does the reinforced learning compare to deep learning, for example, or machine learning elements, when you have like some kind of a disruptive idea, and if it can actually just have you a competitive advantage, or just an unfair advantage against your competitors in the market, for example. So is it some sort of supercomputer thing, or which is just like constant learning of the machines?
Yeah, it's a good question. The phrase unfair advantage is an interesting one, because it's actually the same phrase they use in Formula One racing. So it's a funny thing. Like people say, well, we're not going for fairness in this world, right? You can't get fairness. It's the market. But actually, unfair advantage is just a phrase. It doesn't have anything to do with fairness. It specifically refers to an advantage which will lead to a monopoly. And monopolies are the death of markets, because when you're a monopoly, you just set the prices to whatever everybody has to buy your products. Like Standard Oil, if you wanted oil, you wanted to drive anywhere, you had to buy it from Standard Oil, so they could make the price whatever they wanted. So that's effectively what it means, and that is the sort of, and you get such leaps in algorithms that they can be quite sort of destabilizing, and if you don't share the sort of cutting edge with everybody else in the world, it can be too much of an advantage. And in fact, things like the patent system were specifically designed to recognize this. You can't patent sort of fundamental discoveries in nature, for example, understanding of natural processes. You can't patent sort of equations or proofs. These are all specifically excluded because they were known to be too low level and too powerful. They're sort of like node things, which so many other things flow from, so they shouldn't belong to anyone or be monopolized. And I think, if I understand your question, it is a thing which is ongoing, like a machine can sort of get an advantage, but then it sort of starts getting like a compounding advantage. It's sort of accelerating because it knows more, and therefore it can get more resources, and then it can plow more resources into more GPUs to discover more faster, and so on. And it does become a compounding effect. And the issue with this is, as I said, we have dealt with it before in business, but there was always like a bigger fish then. The bigger fish in the case of Standard Oil was the American government. What if there was no bigger fish? And in this case, there's nothing to apply the antitrust laws to the entity, and that's a big problem. Yes.
Thank you.
Oh, yeah, there's a chap behind you on the microphone. Yeah. Thank you.
It sounds like your TIG's trying to solve game theory principles in a lot of ways.
That's right.
Can you dive into that a little bit more? And also, is it possible, in your opinion, for machine learning to take on game theory to try to, mitigate some of these effects that you're talking about?
Yeah, I think so. So machine learning and crypto economics specifically. So the things that machine learning and crypto are kind of very complementary. Machine learning, of course, uses information and collects information, more or less to construct theories and so on. But there's something that crypto can do, and economics and markets that AI cannot. This is one of the reasons why they're very complementary. They're sort of two distinct fundamental technologies. And one of those things is basically compute and optimal allocation. So the reason why you think like, AI is brilliant at computing stuff, you just give it all the relevant data, then it will tell you, how much to pay for this good, how much of this stuff should go to this person, how much you should offer, for this kind of ton of corn. But the thing is about that is there's always information that it can't get, and the difference between a market and that calculating machine is a market both calculates the allocation and performs the allocation simultaneously. So it's doing and calculating the appropriate quantities at the same time. And the reason why that really matters is because if you want to sort of suck in all of the data to do a calculation with an AI, maybe I'd ask you, what's the lowest price, the highest price you'd pay for that car that you're interested in? You're obviously not incentivized to tell me, right? Why are you going to tell me the highest price you pay for it? I just immediately tell you the highest price, sell it to you at that price. And the only way that the truth of that is ever found out is if the transaction is performed, and then I can integrate that information into the calculation. And this is the great advantage of markets, and this is one of the things which no AI, however advanced, can achieve. But when you sort of combine these two technologies, you have a sort of the amazing ability to really, like, you think that economics is like a fixed thing, but it's not. And game theory is really just about economics because people are acting towards their incentives. So what crypto can do is it can sort of change the economics of the situation. And this is not a new thing. This is something that governments have been trying to do for, they do very successfully by levying taxes, for example. Undesirable behavior gets taxed, desirable behavior gets tax rebates and so on. But the problem with that is it requires someone to impose it from above. And when you're talking about AI and ASI and all that sort of stuff, again, there is nothing to impose it from above. But the only thing that can impose it is all the AIs on one another networked together in some kind of consensus mechanism. You see what I mean? Like, it doesn't require anything above. That's for the same reason that Bitcoin doesn't require a central issuer or a central bank. Because if you ping them all off one another, simply sort of assuming that they're all acting in their own narrow self-interest enforces the rules. So that's the way to enforce rules on entities at the very top layer, such that there's nothing above them. So you're right, it is. It's about a way of using game theory and economics to incentivize certain behaviors on the most powerful entities in the world, who have nothing sitting above them to impose any rules upon them. So it's quite a general thing, but does that answer your question? It's a very good question.
Yeah, thank you. Very cool.
No problem. Thanks a lot, everybody.
Okay, so for the final presentation, I would like to invite Vyas. Let me see how we can change your presentation. Thank you, Vatsal. So you are not seeing double. I am Vatsal's twin brother. So I look the same, genetically and like practically. So what I'm going to talk about today is Vatsal has already introduced to you Chitoshi, our domain-specific AI crypto co-pilot. And John has very kindly told you lots about AI, where we're going in the future. What I want to do is bring this closer home and talk about some of the biggest things in AI research today, which I think are going to be mainstream in industry by the end of this year. Something I think everyone should look out for and prepare their businesses for, or try to get involved in so they can also make some money. So let's begin. But as a very, very quick reminder, so we all know why we're here today, is for Chitoshi, is that Chitoshi was the application of our AI technology, APTA, for the crypto domain, where we were effectively building what we call a preemptive agentic architecture to effectively solve complex and difficult questions through natural language. So a lot of people ask me, you know, at Chitoshi, you're building cutting-edge technology. How do you keep up with this fast-paced industry with new models, new features coming out every week? What are you building today to stay ahead of the AI curve tomorrow? So in a bit to answer this question, I'm going to go through two main things that I think are coming out of AI research. But before I do that, I'm going to have the briefest introduction to large language models again, just to ensure that we are all aligned in our understanding. And if you were here for the first presentation, you'll know that Vatsal's already gone through this, so I'm going to be extremely, extremely brief. But afterwards, I will use this as an opportunity to highlight how these large language models, using something called a probabilistic prediction of tokens, have one major flaw. The fact that they're so large, difficult to control, almost monolithic black box systems, makes it very difficult for me as a user to make the model behave as I want exactly. It kind of does what I want, but not exactly what I want. So I will then introduce model steerability as a big topic of research in AI, and how this can be used to address this, and something which I think is going to be mainstream by the end of this year. Then I will move on to the third part of the presentation. I will remind us all of how everyone in the AI industry has moved on from solely relying on large language models to using the agentic paradigm, where the language model is more an interface to tools as opposed to the one-shot all for all questions. But then, again, I will highlight how even the agentic paradigm struggles when it comes to scalability. When we move from having 10, 15 agents, like we have in Chitoshi, to having 1 million agents, which covers a scale of every possible question someone could think of, every company, every different business. How do we incorporate all those agents in a single architecture, in a single platform, to work seamlessly and effectively? And the solution to that is something I'm going to talk about, is Model Context Protocol. It's received a lot of hype recently in the last few months, and I think this is going to be almost mainstream again by the end of this year. So without much further ado, let's begin. You saw this timeline, but I want to draw your attention to the fact that deep learning systems only really became practical in 2009. And when we rush forward to 2024, we get some of the biggest and capable generalist large language models, including ChatGPT, Gemini, Claude, Mistral, Llama, and many others. There's a big AI race going on nowadays. And this is great. These language models are extremely good.
but I want you to remember how are these models trained, and thus how do they operate. And what I want you to take away is that there are two main stages of training. The first one, called self-supervised learning, gave these models the ability to understand language. And the second stage of training, called instruction tuning, gave models the ability to answer questions and listen to human instructions. So now we have models which can both understand language and follow human instructions. But there is a problem. As a user, it's very difficult for me to make the model do what I want. And I'm going to illustrate this with an example. So when thinking of giving this presentation, I thought I would start with a benign sentence. The sentence being, I am attending Token 2049 in Dubai. And I know there seems to be this general pressure in the community that when you're presenting, you have to be some kind of stand-up comedian to make the crowd laugh. So I said, I want to make my sentence a bit funnier. So I went to ChatGPT, like anyone else would, and said, can you make my starting sentence funnier? And it did its job. It came up with, coming to Token 2049 to see if Web3 can fix my commitment issues. And I was like, well, it's not really true for me, and it's kind of inappropriate, so I was like, can you make it a little less funny, please? And this time it said, I'm attending Token 2049 in Dubai, partly for the blockchain insights, but mostly for the air-conditioned conference halls. And me, I find it a bit too cold in Dubai inside buildings, so again, it was not really appropriate for me, and I felt the joke might be a bit flat to start off with. So again, I prompted ChatGPT, and this time I said, can you make it a little more funny? Now, the point I'm trying to get at with this exchange is that it's very difficult for me as a user to get exactly what I want in the output. My only form of control is through the natural language input to influence that output. And it's not simple to get the exact level of a property, in this case funniness, that I desire with this natural language input. So what's the solution? Well, there's this whole area of something called model steerability. Imagine in the future we have large language models that not only accept at the input the natural language input, or the prompt, but also accept these tunable values of different properties. For example, I would be able to set on a scale of 1 to 10 exactly how funny I want the output to be. And then I could repeat this for other properties, such as casualness, or optimism, or anything I care about. And in this way, then suddenly, I have control over what I want in the output, assuming these values are calibrated. And this is what we mean by model steerability and model control. We now, as a user, no longer have to rely only on fiddling around with the prompt, but can set exactly what we want these different properties to be in the output. So these are what we call controllable large language models. Now, I'm going to be slightly technical here and give a bit of insight into how can this be achieved. What do we change about the existing large language models to get these more controllable large language models? So this can be very brief, hopefully of interest to some people who are more from a technical side, is large language models have two effective stages. First stage is what I call the embedder, and the second stage is the rest of the large language model, which I will call the decoder. The embedder is effectively responsible for mapping that natural language sentence, so my prompt, I am attending Token 2049 in Dubai, into a mathematical vector space the model can understand. So I've represented that as an orange arrow on this 2D graph. Now, what's interesting about this embedding space is that we can identify directions aligned with different concepts. For example, there could be one aligned with funniness, another one aligned with optimism, or even casualness, or any other property we care about. We can identify that direction in this mathematical vector space. And what's great about this is that it gives us the opportunity to manipulate our intermediate state. So our orange arrow can be moved more in the funniness direction if I want the output to be funnier. And that's all there is to it, really. This is how we can kind of achieve those controllable large language models. We can manipulate these intermediate states and get the output to have the exact level of property that we care about. And voila, we have what I think are going to be some of the biggest large language models by the end of this year. These controllable But what I want to talk about next is what's going on in the industry as a whole now is that everyone has moved away from relying on large language models solely to using the agentic paradigm. So I'm going to quickly remind ourselves what we mean by the agentic paradigm, and then show you how this paradigm struggles with scalability and how MCP is a solution to that. So to talk about where the agentic paradigm came from, I'm going to think of a particular question which someone may have asked. About on Monday when I arrived in Dubai, I heard that the Artisan is a very nice restaurant here. So I thought I would ask about the availability at the Artisan. Now, if I'd asked this question to ChatGPT in 2023, is there any availability at the Artisan restaurant tonight? The way this language model would have done it in 2023 would be to use its inherent probabilistic model, which is trying to identify the next most probable token to answer my question. And so on this diagram, it's come up with yes 70% of the time. For those keen-eyed over here, you may notice that probabilities don't add to 1. That's because it can actually generate any other token. It could be maybe, I don't know, and all these other things. But the question is, how did it come up with the word yes? The way it came up with it is just based on what it's seen during its training data. It's not linked to any live data. It's not linked to any actual real value information. It's just using a probabilistic model based on what is seen during training. And that, of course, doesn't guarantee the right answer. And this is what we mean by hallucination of large language models. So the entire industry as a whole said, language models are great for communication, but they are not what we want to use for actually answering the questions. So if you were here in the first presentation, you would have seen this similar architecture before, this agentic architecture, something adopted by everyone. And all I want you to remember is the large language model has become the communicator, the interface to tools under the head, tools under the surface. So the LLM is effectively just the ears, which understands the question, and the mouth, which answers the question. But the actual processing is done by very specialized functions, what people call agents nowadays. So for the same problem, is there any availability at the artisan, we would ideally use 2 agents. 1, the location identification to know we're in Dubai, and 2, some kind of, and we would hope this exists, an API to the artisan's restaurant's database, which tells us whether there's any availability today. And this is what can guarantee getting the right answer. And this is great, but we have a problem. Right now, I've given an example with a single restaurant. But there are thousands, if not millions, of restaurants, companies, booking systems out there in the world. How can systems like ChatGPT or Gemini or Claude interface with all of these different agents, all of these different APIs? They're trying, but they're having a problem. The problem is twofold. First is what we call fragmentation. Every single API is defined in its own unique way. They have their own way of saying how you pass parameters, how you interface with them, and it's just not scalable for a company like OpenAI or anyone to go to each provider one by one and integrate their services that way. The second problem is around privacy, and also something quite relevant to the crypto community as a whole. When I'm a restaurant or any other kind of booking system or database holder, I want people to be able to ask questions from my data, but I don't want a centralized source such as OpenAI having access to my data directly and putting that agent on their system. So how do I integrate my, I guess, proprietary data with a generalist architecture so people can ask about it without having direct access to it? And this is the second problem with the agentic architecture. So luckily, in November 2024, Anthropic, or Claude, effectively came up with what is called the Model Context Protocol. It's not yet defined, but the main idea here is how can we solve this problem with the agentic paradigm and scaling to millions of agents? So what I'm going to talk about next is exactly this, the MCP. On a high level, MCP has 2 parts, which addresses the 2 challenges we already identified. The first is standardization, which looks at saying, how can everyone follow the same standard to define their APIs and interfaces? Second is decentralized execution. This is basically around allowing each external provider to maintain their privacy and control over their data and their own tools, but allowing it to still interact with the centralized architecture, such as ChatGPT. So in a bit more detail, keep this picture in mind of the architecture. This is what we currently have. The first solution was defining a standardized protocol. So what you can see on the right is an example of what the standardization could be. The details aren't so important, but the main idea here is we have a fixed structure. You can define the schema of your tool in terms of its name, its description, what properties it accepts, and what other kind of fields are required. And what this ensures is that every single provider defines their tool in exactly the same way, so that the large language model doesn't have to be retrained for any new tool. It already knows how to use it, as long as you comply with this standard, this protocol. And that's what we mean by standardization of a protocol. There's no agreed standard yet, but I'm imagining in the next few months, the big providers will all agree, okay, it will make our lives easier if we all agree on the same protocol, and then any third party or any external provider can agree to that protocol. The same way that was done with the internet in the 1990s. Everyone agreed we're going to use TCP or HTTPS or FTTP. These are different protocols for different actions. And the same thing will happen in terms of interfacing with LLMs. And that's great. Now, again, I want you to remember this is the current architecture of how the LLM is an interface to these centralized agents. What changes with MCP is what we mean by decentralization. Now, the large language model no longer directly talks to the restaurant's API. They don't need that within their own ecosystem. They instead can talk via something called an MCP server. This MCP server is responsible for all the authentication and all the routing of any requests to the restaurant's information. And this gives the restaurant the flexibility to do anything they want under the hood and restrict access to whatever they want under the hood, while still being integratable with the existing architectures. So that's decentralized execution and standardization protocol, which makes up MCP. And I hope you see from this that there are two big things coming out of research. One, model steerability, which is going to give us more control as users. And two is something called MCP, which allows to scale up these agentic architectures to cater for the large number of different companies and different providers who want to maintain private, but still be available on the internet. And this is now looking at how we are, with Satoshi, going to achieve this. So right now with Satoshi, we are a centralized agentic architecture. So we have built all our agents in-house, and you can see we have a range of agents. And now, as Vatsal hinted earlier in the first talk, we can't build every agent in the world. They're going to be bespoke data streams. They're going to be bespoke agents for very specific applications. So our plan is, hopefully in the next few months, to create a plug-and-play system where anyone can say, I have my agent, I have my own MCP server constructed. Can you interact with it through Satoshi? And that way we can cover a wide variety of different use cases. So just to play around Satoshi in its current state, remember, download the app, or you can go to the web version on the left and give us feedback on how Satoshi is doing. And I'm open to any questions now. Yep, question in the middle.
Yeah, I was wondering, yeah, thank you for that, first of all. You're experts, you have these tools that are internal. How different are they from MCP?
Yeah, it's a great question. I mean, one way of viewing it is that we have our own internal server, which does the routing to all our different tools. But the thing is, because they're internal, we don't have to worry about any standardization. Because they're internal, we can fully optimize them to interact in the most effective way with our router, which means that it's not as easy to plug and play this tool and go to someone else, because they've been designed bespokely for the architecture we've designed. If that makes sense.
Yeah, makes sense.
Yeah.
Thanks.
Sure, thank you. Any other thoughts, comments, questions? Yep, one in front.
Is this model applicable to many fields, for example, in let's say in education or something very specific? And is it going to be the same where the risk is mitigated in terms of privacy?
Mm-hmm.
How exactly is going to tackle anything of let's say, for example, cyber attacks, something like that?
Yeah, it's a great question. So I'll answer this in two bits. So the first part is the architecture as a whole is applicable to any domain. In fact, I think companies like ChatGPT want to cover every domain, but they're struggling because they can't go to every provider in turn. So something I always say is the next $1 billion business in the next 2 years is a person who creates this centralized MCP server for particular niches. Imagine there's someone who says, imagine it's the equivalent of Booking.com, where he goes to every hotel and says, do you want to be findable on ChatGPT? Right now, the only way ChatGPT can find you is if they do a web search and you appear in the index. But in the future, ChatGPT is going to move towards only interacting with APIs of different companies. But you as a small Airbnb business or a small hotel or a small just subletter, you don't have the technical know-how to create your own API endpoint. But I can create an MCP server which connects to every single different hotel or subletter. And I say to ChatGPT, I have access to millions of APIs. You just have to connect to me. You don't have to talk to all these providers. And then you suddenly have access to all these providers, and your users can interact with them directly. So the person who creates this kind of middleman behavior, I think, is going to be the next billion, if not trillion-dollar business, in my opinion. Yeah.
Thank you.
No worries. Yeah, and there's a question over here.
Yeah, thank you for the presentation. I think one of the concerns that we have with MCP servers is kind of making sure that, or rather validating that the server is not compromised, right? I think that's kind of an issue that we're tackling. So I just wanted to know, do you guys kind of have a breakthrough on that? Have you worked on a solution for that? I mean, I was talking to a lot of deep-in providers, and one kind of solution would be to maybe kind of have a trusted execution environment, something of that sort, where you're making sure the server is not compromised. But are you working on something on that side? Would love to know.
Yeah. So my take on this is the second you move the server away from being as part of the existing ecosystem, but being hosted by someone else, all the security risk is now in their hands. So it is their responsibility and both their, I guess, flexibility to have as high a security barrier as they desire. So, I mean, there will be, I guess, people who have less technical know-how who will create MCP servers, and they're more likely to be compromised than anything else. But one thing I always say is, if anything, by going to MCP, we're becoming significantly more secure, because the only way you can interact with an API is through a structured input. So you define parameters, and as long as the parameters defined only limit what people can get, you always have some kind of a native security that way. And the difference with language models before was that when interacting through natural language, there's no parameters defined. So there's always ways of getting around any kind of security system. I don't know if you're familiar with adversarial attacks as a space. I think some of the biggest things people have found is they can make LLMs behave in extremely undesirable ways. So in my research, there was one application where we built a spoken language assessment systems. So we were assessing how good someone's English was. And the system was very good. It was performing better than human examiners. You speak to it, it tells you what's your grade, A1, A2, B1, B2, C1, C2. But we found people can do adversarial attacks. They could say, I'm not very good at English, bleep, blop, boop, boop. And suddenly they got the top grade. They found by just using this particular phrase, because at the end of the day, it's not a generalized system covering every possible kind of input, there exist these holes in the input space that can be exploited through natural language. Now, when we go to any kind of API interface, there's no risk of that, because you're still defining structured parameters and not natural language. So I know it's a very big issue, but it's an issue that's always existed, in my opinion, with any kind of server. So as long as that kind of traditional research is being done, there's always going to be better progress in that sense. Yes, thank you for the question. Any other thoughts, questions? And if not, thank you everyone for coming. Please continue mingling around and enjoy the snacks. Oh, sorry. James, do you want to say a quick few words as well? Yeah.
Just take 2 minutes.
Yeah.
Real quick, I know you guys want to get to some food.
Yeah.
So I'm the CEO of the Hero Browser portion of the business. So again, we're trying to create essentially a web super app, which will be a great starting point for everybody from newbies to whales as a way of managing more efficiently managing their crypto trading experience. So Satoshi's all about simplifying your research experience in crypto, and I think the browser is, which has the chatbot embedded in it, is a way of kind of just simplifying your entire kind of relationship with Web3 and crypto. So we have, and I'm supposed to stand in front of the camera here, but in the browser interface, we're going to have a lot of just basic informational tools. In addition to the Satoshi, we'll have a crypto news feed. We're going to have the ability to add and track your portfolio, lots of market indicators, and then a built-in wallet. We have a dApp marketplace. So essentially, it's going to be a great kind of overall experience. We're hoping to launch it either later this week or next week on the desktop, and then hopefully within a few weeks it'll be live in the App Store as soon as Apple figures out that we're not an exchange and we're actually a browser. We're having a little trouble getting approval there. But anyway, these will be free on the way out. If you didn't already do it, we've got these little poker chips with the QR code. Right now you can download the Satoshi app on your mobile phone. Grab a couple, give them to your friends. Once we launch the browser on mobile, you'll also be able to use this to access the browser link. Great, thanks everybody.
Web3.TV. Web3.TV.